A streamlined car flashes by at over 300 kilometers per hour. But there's no sound of an engine. This is an electric car, propelled by motors and batteries. With 8 wheels and more than 600 horsepower, it's a genuine supercar. It was developed by Professor Hiroshi Shimizu of Japan's Keio University. For over 20 years, he's been developing electric cars in a quest to promote adoption of environmentally friendly vehicles.
電気自動車が環境に優しいだけでは社会に普及しないと考えています。これまでの車に比べて性能的にパワー的に高いものを持って初めてそれが普及するというふうに考えています。
Previous electric cars have been seen as lacking in power and speed. But the car Shimizu is developing is intended to reach 400 kilometers per hour. It will be the fastest electric car ever made. A high-performance car with no exhaust emissions. Follow along as 1 year in its development unfolds. The electric supercar is named ELIICA. Full-scale development got underway in September 2003. On this day, Shimizu was working out details of the ELIICA's body using a full-scale clay mock-up.
この面もこの面もきれいに仕上げていかなければ出ない。
私見ると合格点。あ、そうですか。
Typically, only experienced engineers working for a car manufacturer can develop a car from scratch. But Shimizu has never been affiliated with any car manufacturer. While teaching university classes on environmental issues, he works with students in the lab to develop electric cars. Working to turn his vision into reality, he has funded a series of electric cars by applying for grants from government projects. He has received no support from car makers. This will be the 8th electric car his lab has made. Shimizu first tried his hand at building an electric car in 1983. He took the engine out of a used car that he got from a friend, then fitted the car with batteries and electric motors. At the time, he was working at the National Institute for Environmental Studies and was an amateur at building cars. So why did he begin electric car research? It all started with an instrument he developed to measure air pollution using laser beams. This pioneering development enabled instantaneous measurement of air pollution across the whole Tokyo metropolitan area. But Shimizu felt that simply taking measurements did nothing to actually solve environmental problems. Sensing the limits of his current research, he began to see the potential of electric cars. After making 4 prototypes, Shimizu conducted full-scale development of an electric car in 1996. The result was a compact 2-seater called Lucio. Shimizu was proud of the little car, which could do 150 kilometers per hour, be recharged at home, and squeeze through narrow streets. He promoted the car in Japan and around the world. People who test drove it gave it high marks. But no serious buyers materialized, and to Shimizu's disappointment, there were no inquiries from car makers.
ルシオールはかなりうまくいった車だという自信がありました。しかしそれでもまだ社会で受け入れられるには足りないということを強く感じまして、電気自動車は環境に優しいということだけでは普及はしないということでした。で、それをもし普及するとしたらガソリン自動車にない何かというものが必要だということですね。でそれはまさしくパワーだということです。でパワーということは速いと、あるいは加速がいいということなんですね。それがガソリン自動車に加えられない限り電気自動車というのは普及しないというふうに考えたということでした。
To develop an electric car with better performance than a gasoline car, Shimizu partnered with industry for the first time. He recruited companies that included makers of motors, batteries, and other components, a total of 35 partners. This brought Shimizu 500 million yen in funding and access to specialized expertise. Shimizu's electric car development is being undertaken by manufacturers that are not involved in conventional car making. The motors that will drive the car are crucial. This factory builds custom-designed electric motors. To take the car to a speed of 400 kilometers per hour, Japan's high-performance motor technologies will be essential. ELIICA runs on 8 wheels. Each wheel has a motor inside it. The motors are each 18 centimeters wide, and each of them must produce 80 horsepower to take the ELIICA to 400 kilometers per hour. The key to achieving this power is the coils inside the motors. A coil's strength is determined by how densely it's wound with electric wire. Shimizu has assigned this task to Yoshio Kato, an engineer with 40 years of experience. Kato will need to push his coil winding skills to their very limits. No one has ever managed to wind a coil so densely that it can generate such high power within such small dimensions. Conventional winding methods make the wire protrude, so the coils won't fit in a motor that's only 18 centimeters across.
たくさん真っ赤ですね。これはね、もうなんとかこれをでも少しでも何回か試してもこれを中側へ飛び出せないようなことまでやらないと製品になりません。
Through trial and error, Kato comes up with a winding method in which the nozzle that feeds out the wire and the holder for the coil both move. This allows wire to be wound more densely than ever before.
これはきれいに巻けて、やっぱりこの方法でないとダメみたいだね。 これなら十分問題なくいけると思います。
こういう努力に支えられてなんとかやってきたというところですけども、
それを先生がみんなまとめておられるんじゃなくて、先生がいないとみんなバラバラで何の役にも立たないんです。先生が要になってるからみんな僕らが力を発揮できるもんです。
Japanese technology has realized these tightly wound coils, but the coils alone are not enough to produce 80 horsepower. There's another vital ingredient, a revolutionary permanent magnet technology for the motor shaft. A rare earth permanent magnet of unprecedented strength is used. Invented by a Japanese manufacturer, it's said to be the world's strongest magnet. It can attract 5,000 of these steel balls. The magnets in just one of the ELIICA's motors can hold up a steel mass of more than 1 ton. This kind of magnet enables a motor more powerful than any other to be built.